Okay, I want you to imagine a virus for a second, but not one that just steals your passwords or locks up your computer or, deletes some files. Imagine a piece of code that literally shattered massive industrial machines thousands of miles away, all without a single bomb ever dropping. Welcome to this explainer. Today we're diving deep into Stuxnet, a piece of code that fundamentally changed our entire understanding of modern warfare.
So, can a computer program physically destroy a factory? I mean, it sounds totally like science fiction, right? Like some hacker movie plot. But I promise you, this isn't Hollywood. We're exploring a very real, incredibly chilling historical reality, where a seemingly simple computer program actually managed to set an entire country's nuclear program back by years. No missiles, no explosives, literally just lines of code.
All right, let's jump into Section 1, the invisible physical threat.
Back in 2010, cybersecurity researchers all over the globe stumbled onto this massive, frankly terrifying anomaly. Now, up until then, we were mostly used to traditional malware, right? The kind built to steal your credit card data, maybe siphon some money or deface a website. But Stuxnet was completely different. It was specifically designed to target industrial machines. We're talking about the actual computers that control massive physical factory floors. This was the moment we saw a terrifying leap from digital theft to real-world physical sabotage.
Moving right along to Section 2, targeting industrial machines.
The specific target of this attack was Iran's nuclear program, and a facility packed with some incredibly sensitive hardware. To really grasp the absolute brilliance and the devastation of this attack, you have to understand the hardware. The target was centrifuges. A centrifuge is basically a machine used to enrich uranium, and it does this by rotating at insanely high speeds. And because the physics involved are just so delicate, if you alter that rotation speed even slightly, the machine can quite literally tear itself apart. We're talking about destroying millions of dollars worth of equipment in just a matter of seconds.
Which brings us to Section 3, breaching the air gap.
Now, the defenders of this facility had what's known in the cybersecurity world as an air gap. If you're familiar with the term, you know it means the system is completely physically isolated. There's no Wi-Fi, no rogue Ethernet cables connecting it to the outside digital world. Because of this, an air-gapped system is theoretically considered unhackable from the outside. So, the million-dollar question was, how on earth could a virus possibly infiltrate a completely isolated, lockdown system?
Let's look at how they did it in Section 4, the silent sabotage.
How do you beat an air gap? Well, it played out exactly like a tense spy thriller. The physical barrier wasn't breached by a digital download over the internet. It was breached by a physical object. The virus made its way into this highly secure facility via a single infected USB drive. It was likely just plugged in by an unwitting employee who had absolutely no idea what they were carrying in their pocket. And this is where the dark genius of the whole heist really shines. Step 1. The USB is inserted. Step 2. Stuxnet doesn't just attack right away. It's patient. It silently spreads through the network, hunting for its specific target. Step 3. It finds and hijacks the Siemens PLC. That's the programmable logic controller actually running the centrifuges. Step 4. It maliciously alters the motor speeds. It pushes them dangerously fast and then suddenly drops the speed, forcing catastrophic physical damage. And then there's Step 5.
Step 5 is where we get this absolutely chilling quote. The machine was failing, but the screen showed everything was fine. You see, the virus was so deeply sophisticated that it actually intercepted the sensor data. It fed fake, perfectly normal readings right back to the control room. So picture this. The engineers are sitting at their desks, looking at green lights and totally stable graphs on their monitors, completely blind to the fact that mechanical destruction is happening right in front of them on the factory floor.
Let's move to Section 5, uncovering the cyber weapon.
Now, this silent sabotage, it was supposed to stay completely hidden, locked entirely within the walls of that specific facility. But a tiny error in the code changed history. Stuxnet accidentally escaped onto the global internet, which instantly alerted the world to its existence. Once it was out in the wild, cybersecurity firms everywhere basically pounced on it. They spent months painstakingly unraveling this incredibly dense code, and what they realized was staggering. This wasn't just some clever malware. It was a weapon of mass disruption. Honestly, it was easily one of the most complex and intricately designed cyber weapons ever discovered in human history.
So, the most crucial question here is who actually built it? Well, officially, the creators remain unacknowledged.
To this day, no country has actually stepped forward to claim responsibility for Stuxnet. But if we just look impartially at the facts of the code itself, the massive resources, the sheer years of development time, and the extreme engineering expertise required to build something this complex, all of that strongly indicates the involvement of nation-states. This wasn't just some lone hacker in a basement. The design points squarely to a highly funded, heavily resourced government operation.
And that brings us to Section 6, a new era of warfare.
Stuxnet completely ushered in a new era of warfare, and it put the physical infrastructure that you and I rely on every single day at risk. Think about it. The power grids keeping our lights on, hospitals keeping people alive, factories producing our goods, and the complex urban systems managing our cities. Stuxnet essentially proved that if an attacker can manipulate the code running these systems, they can physically break them. Cybersecurity evolved practically overnight from a basic IT headache into a critical, urgent matter of national security.
Which leaves us with this final, pretty provocative thought. If just a few lines of invisible code can physically destroy highly secured, air-gapped industrial machines, how safe is the infrastructure that keeps our everyday world running? Thank you so much for joining me on this explainer. I really hope this leaves you looking at the digital networks all around you in a completely new light.